Hello, Algebra 2. Welcome to Unit 1, Day 1. Let's get started. This section here, just read through that on your own time. Familiarize yourself with all of that in order to be able to determine whether or not it's real, rational, integer, whole, irrational. If you have any questions on that, please let me know. Also, looking here, 1 through 9, they want you to reorder and put in the appropriate order from least to greatest. And I'm not going to be spending a lot of time on that because I assume that you would know how to do that. But if you see the answer key and you're not getting these right, talk to me. We'll go over this. This one we will do, though. This one requires some math. And I like doing that. You have to do your order of operations whenever you see an expression. Parentheses first, PEMDAS. Remember PEMDAS. So parentheses first. We want to first simplify what we have here. 5 minus 3 is 2. Okay, next. We're taking care of our parentheses. Now we have an exponent that we need to take care of. Now, the only thing that is being squared here is the 7. Just the 7. And by the way, plus, minus, that's just, it's going to simplify to minus. 7 squared is 49. You're taking care of the exponent. Now comes multiplication, division. We do have multiplication. We are distributing. Let's distribute this 49 to the 2. What is that? 49 times 2, is that 98? I think. 49 times 2, 98, yeah. And now that we've done the multiplication, do we have any addition, subtraction? We do. 1 minus 98 is negative 97. And that is your final answer. Move over to side 2. All right, evaluate negative 3 squared. Anything you're squaring means you have 2 of the exact same thing. But you would have to write this out if you know what the answer is, but I'm just giving you a demonstration. And negative 3 times negative 3 is positive 9. Now let's compare that to this negative 3 squared. The only thing that we're squaring is the 3. So another way of writing this would be like that. 3 times 3 is 9. Keep the negative. So anyway, 9, negative 9. And then here, the final answer would be negative 9. Example 1, simplify. What we're doing here is we're just combining like terms. Notice that there is not an equal sign. This is not an equation. So we're trying to find like terms. Negative 2a we could combine with positive 6a, which would give us 4a. Let's see. 5b, negative 7b. 5b minus 7b is negative 2b. Oh, look what I did. I forgot that there's a, oh, missed that one. So let me bring that down. I missed there was another a. And now we can combine these a's because they're like terms. Negative 11, positive 4a, if you combine them together, you get negative 7a minus 2b. Leave your answer just like that. Example 2, we have some simplifying that we can do first. Oh, let's take care of this parenthesis that has the exponent. And as I begin rewriting this again, I'm going to go ahead and start doing some distribution just to speed this up a little bit. So let me just distribute the 2 throughout this parentheses here. Now I'm going to distribute the negative 3 throughout that parentheses. Minus, and then negative 4 squared, it's negative 4 times negative 4. That's now positive 16. Okay, how about I go ahead and I'm going to combine these x's here. 2x minus 3x is negative x. Negative 12, positive 15, that's 3. And when we distribute the negative throughout the parentheses there, we get negative 16. And it looks like we can go ahead and combine these integers there. And now we have our final answer. Leave it just like that. Example 3. Let's simplify this parenthesis first. 50 plus 5 times 2. Let's do the multiplication first. 5 times 2 is 10. Now combine 50 plus 10. Okay, let me wrap that around some parentheses around that 60 minus, open a set of parentheses, 12 minus 8 is 4. And then plus 4 squared, that's 16. Now the parentheses are no longer needed. And now we can combine all those integers, get our final answer of 72. Example 4. When you see a problem like example 4, you want to simplify the numerator completely, and then simplify the denominator completely, and then see if you can simplify numerator over denominator. All right, so what we need to do here first, 10 minus 16 divided by 2 squared times 2. We got a lot going on here. There's no set of parentheses, but there is an exponent, so let's do that first. Divided by 2 squared, that's 4, and then times 2. Okay, I'm going to write down this little sheet right here. PEMDAS. Now, it's clear we start with parentheses, then we start with exponent, and what is very commonly misunderstood is you then do multiplication next if you happen to have multiplication and division in the exact same order or in the problem that we're solving for, and that is not the case. These hold the same weight. We do whichever one comes first from left to right. So the first thing we're going to do is we're going to do 16 divided by 4. 16 divided by 4 is 2. Now we're going to multiply the 4 and the 2. And 10 minus 8 is 2. So now we know that in the numerator goes 2. All right, let's start simplifying our denominator here. 7 minus 4 squared. 4 squared is 16. 7 minus 16 is negative 9. There's the numerator. There's the denominator. So 2 over negative 9. Can we simplify further? No, don't be silly. That's your final answer. Now we are evaluating expressions. Always use parentheses when substituting! Exclamation point. Okay, then we shall. X times y times z squared over negative x times z. Well, let's see. What is x? According to our little chart here, x is the same thing as negative 1. So let's substitute. Okay, what is y? According to the chart, y is the same thing as 4. Z squared, z is negative 2. Look at where the square goes. Look at that, outside the parentheses. Over negative, open parentheses, what was x again? Negative 1 times z, z was negative 2. Okay, let's simplify numerator first. Negative 2 times negative 2 is 4. Multiply all that together, we're going to get negative 16. Now, let's simplify our denominator. Negative times a negative times a negative. You see there's an odd number of negatives there that we're multiplying. That means our final answer is going to be negative. And 2 times 1 times 1, 2. Okay, now that we have fully simplified numerator and denominator, can we simplify again? Absolutely. Negative 16 over negative 2 is positive 8. Beautiful. All right, these vertical lines there, they're not parentheses, but we're going to treat them like parentheses in a way, but they also have another meaning. They're called absolute value, and I'll show you what that is in just one moment when we get to where that information is relevant. Okay, 2 times y. What is y? 4. Plus z. What was z? -2. Plus y times z. Okay, let's start simplifying. We are going to treat the absolute values as if they are parentheses. Let's do that first. 2 times 4 is 8. Plus -2, well, that's just -2. And 8 minus 2 is 6. Plus 4 times -2. Well, 4 times -2 is -8. And plus -8 is just -8. Okay, now the absolute values. Once you've simplified what's inside the absolute value fully, you then look at that number and ask yourself, on a number line, how far away is +6 from 0? Well, it's 6 spaces away. So the absolute value of 6 is 6. The absolute value has now served its purpose. So we can use parentheses. You can now distribute. And now you can combine your like terms for our final answer of -14. Example 7, -4. Absolute value. What is W? -1/2. -1/2. Okay. Now the absolute value, we're not adding anything to -1/2. We're not subtracting, we're not multiplying. So now we just simply ask ourselves, what is the absolute value of -1/2? How far away is -1/2 from 0 on the number line? And the answer to that question is 1/2, positive. Absolute values will always produce a positive result. And now -4 times 1/2 is -2 for your final answer. Solving linear equations. Let's do it. Let's distribute this -2 throughout the parentheses. And now let's distribute the 6 throughout the parentheses. Right side of the equal sign. Okay. Now notice on the left side, we can combine some like terms. Let's do that first. -8, +7, combine them together, you get -1. Okay, next, we can combine these x's here. I'm going to do that by subtracting 6x and bringing it over here. Well, 6x minus 6x is 0 or 0x, doesn't matter, 0 or 0x. I'm happy with either one. Now let's add this 1 and bring it over here with the 6. 6 plus 1 is 7. Now, in order to get x by itself, divide away the 0. X equals, well, 7 over 0 is the exact same thing as 7 divided by 0. And you know what? You can't divide by 0. You can't have 0 in the denominator. Therefore, this is a no solution. No solution. That is your answer. Now, I wrote down 0x equals 7. Let's say you did it the other way. You could have done 0 equals 7. Well, once you get to this point here, you ask yourself, is this a true statement? Does 0 equal 7? No, it doesn't. Therefore, no solution. Example 9, let's distribute the 5 throughout the parentheses. And then over here on the right side of the equal sign, I'm just going to start combining some like terms. I see a +3 and a +7. Combine those together, we get +10. -2x minus 3x. -5x. Okay, now I'm going to move this negative 5x to the other side by adding it over. Negative 5x plus 5x, well, that's nothing. So 0. Over here, let's subtract 10, let's subtract 10, 0. Okay, now look at this. 0 equals 0. Is that a true statement? Yes, it is. Therefore, all real numbers. That's your final answer. Example 10. They want us to solve this by clearing the fractions, and I would like to take this opportunity to remind everybody that for the most part, in Algebra 2, you will not be allowed to use graphing calculators, unless, of course, you have a 504 or a special education accommodation that states otherwise. But most of you don't have that. So you will not be allowed to use graphing calculators and stuff like this. You're going to need to know how to add and subtract fractions at times. You're going to need to know how to multiply and divide fractions and whatnot. And you're going to need to know how to find the common denominator, with typically the most least common denominator. But even if you don't know what the least common denominator is, you can at least find a common denominator. Notice that we have 7 and we have 9 as our denominators. Well, if you multiply 7 and 9 together, that gives us 63, which I'm now going to write above every single one of these terms, and I'll show you why in just a second. Okay. Now, 63 times 3 over 7, W, this is one way that you could go about solving this problem. Ask yourself, how many times does 7 go into 63? 9 times. Now multiply 9 in the numerator. 9 times 3 is 27. Keep the W. Minus, how many times does 9 go into 63? Well, that's 7 times, and 7 times 2 is 14. 9 goes into 63 7 times, and 7 times 4 is 28. Don't forget the W. Plus, how many times does 7 go into 63? 9 times, and 9 times 1 is 9. If you do that process, you have no more fractions remaining. We have cleared them. And now this becomes a little bit easier to solve. Let's subtract 28W and bring it over here with the 27W. Let's add 14 and bring it over here with the 9. Oops, add 14. Gives us 23. Now divide both sides by -1. We can't have our W be negative to get our final answer of -23. All right, when you have a scenario like this next example here, you could multiply 5 times 6 times 10 times 30. That's a really big number. I don't want to do that. So what I'm going to do is I'm going to take the biggest number, 10, the biggest denominator, and I'm going to double it. Well, that would give us 20. Well, 5 goes into 20, but 6 and 3 do not. Okay, so let's start over again. Let's go back to the 10. Let's now triple it. 30. All of these numbers go into 30. That is our least common denominator. All right, let's start simplifying. 5 goes into 30. 6 times 2k is 12k. 6 goes into 35 times 5 times 1 is 5. 10 goes into 33 times 3 times 3k is 9k. 3 goes into 30 10 times 1 is 10. Combine like terms. Let's now divide away that 3. Final answer, k is equal to -5/3. Correction, +5/3. 10 minus 5, 10 minus 5 is +5, not -5. +5/3. Sorry about that, y'all. Okay, we're about to get started with example 12. And if we're going to solve this, I'm actually, as I'm talking, as I'm thinking this out, there's a couple ways that we can go about solving it. We can eliminate the fractions by multiplying by the common denominator. But what I'm noticing is that if I just go ahead and distribute these fractions, it's going to eliminate them from being fractions, okay? So let me show you how. If you're ever going to multiply a fraction with a whole number and you don't really know how to do that, here's what you can do. You can put that whole number over 1. Now watch this. I'm going to multiply numerator times numerator. 2 times 6 is 12. Over, now denominator times denominator. 3 times 1 is 3. Don't forget the c. And 12 divided by 3 is 4c. See that? Okay. Now that I've shown you how to do that, I'm going to go a little bit faster, okay? I'm going to do some cross canceling. 3 goes into 18 6 times, and 6 times 2 is 12. But don't forget there's a minus there. Okay. Plus, now 3 over 4 times 8c. 4 goes into 8. 2 times 2 times 3 is 6. All right. 4 goes into 32. 8 times 3 is 24. Set that equal to negative 18. Okay, let's combine our like terms on the left side of the equal side first. 4c and 6c. 10c. Negative 12, positive 24. And now subtract over the 12. Divide everything by 10. C equals negative 3. Example 13. Now this one, I want to clear my fractions first before I just start distributing. Our common denominator here is going to be 20. Now watch what I do differently here. Notice I did not write 20 above every single number this time. The reason why is if you have something in parentheses, we're not going to multiply that by the common denominator. We're gonna leave that as it is for now. All right, let's start simplifying. 10 goes into 20 2 times, and 2 times 1 is 2. Okay, 5 goes into 24 times, and 4 times 4 is 16. 4 goes into 25 times, and 5 times 1 is 5. Okay, now let's distribute the 2 throughout the parentheses. Combine like terms. And now divide both sides by 14. And we have our final answer. Solving for a variable. Okay, here we are solving for, they want us to solve for d subscript 1. Whenever you're solving operations like these, oftentimes, whatever variable you're solving for, that's the one thing you don't want to move. We want to move everything else away from it. And this is what's going to help us do it. We're going to do our order of operations backwards. We're going to ask ourselves, is there anything that we can add or subtract away from d subscript 1? Well, there's not, because this is all multiplication here, by the way. This is 1/2 times d subscript 1 times d subscript 2. So there's nothing we can add or subtract away from it. What about multiply or divide? Yes, we can. I think in order to get rid of this fraction here, this is what I would do first. I would multiply both sides by the reciprocal. If we multiply both sides by not 1/2, but 2 over 1, or just 2, this is what we get. Notice, just cancel those out. Okay, now let's divide away d subscript 2 from both sides. And now you have your final answer. There it is. Example 14. Now what are we solving for? We are solving for h. So let's not move the h here. I believe it's going to be necessary. We have pi times r squared times h, all divided by 3. So therefore, there is nothing we can add or subtract away from h in this case. But we can multiply something. Let's get rid of this 3 that's in the denominator by multiplying both sides by 3. Threes are gone. Okay, now we're left with 3 times v equals pi times r squared times h. Now we can divide something away. We're solving for h, right? Yes. Okay, so let's divide both sides by pi r squared. And it looks like we're done. We did it. Example 16, patterns and problem solving. Look for a pattern in the table, then write an equation that represents the table. Okay, if you will notice here, the x's they're increasing by 1 every single time. Or y is doing. They are increasing by 4 every single time. Whenever we're given a table of x values and y values, you want to do change in y 4 over change in x 1. And that gives us 4. All right, we now know what the slope is. We now know what the rate of change is. And I'm going to write it like this, m equals 4. All right, take note of this. This is a special set of ordered pair. Anytime x is 0, that tells you what your y-intercept is. Now we can write the equation and slope-intercept y equals mx plus b. Now let's just substitute. There's our equation. Looking at example 17, notice the change in x is still 1. But notice the change in y, it's decreasing. It's decreasing by 10 every single time. Negative 10, change in y over 1. So our slope here is negative. Thank you for giving us an ordered pair where x is 0. Saves us from doing a lot of work. Therefore, our y-intercept is 46. And now we know what the equation of this line is. There's your answer. All right, example 18. 6 more than 1/4 of a number is 15. Find the number. 6 more than. That means we're adding 1/4 of multiplying a number. We don't know what the number is. So normally we say x is equals 15. So let's build this. We're going to start with 1/4 of a number. 1/4 of a number. Now remember that 6 more than? Let's just do plus 6 is 15. And now we can solve and find the number. Let's start by subtracting 6 from both sides. What is that? 15, 14, 13, 12, 11, 10, 9. Let's now multiply both sides by 4. The number is 36. Example 19. I went ahead and set up how you're going to want to begin this, and then just follow along. Josie is selling Girl Scout cookies for $4 a box. She sells 3 times as many boxes of Thin Mints as she does Savannah's. So 3 times S. She sells 6 fewer boxes of peanut butter cookies as she does Savannah's. If her sales of these 3 types of cookies total $376, how many boxes of each did she sell? Now, since we're using Savannah's as kind of our measure of how much we sold of Thin Mints and how much we sold of peanut butter, then we're just going to leave Savannah's as S. Now, let's remember that each of these costs $4 a box. So here's how we're going to set up our problem. Let's start with 4 times the amount of Thin Mints that we sold, plus 4 times the amount of Savannah's that we sold, plus $4 times the amount of peanut butter that we sold. And we're going to set that equal to the dollar amount. And now we're going to start distributing. And now combining like terms, 12s plus 4s plus 4s, that's 20s. And set that equal to, let's add 24 to both sides. That's going to give us 400. Now, if you divide both sides by 20, we will find that S equals 20. So now we know how many Savannah's we sold. Now we know how many Thin Mints we sold. What is 3 times 20? And now we know how many peanut butter we sold. 20 minus 6 is 14. Example 20. The perimeter of a triangle is 33 centimeters. The first side is 5 centimeters shorter than the second. The third side is twice the first. Find the lengths of the sides. Notice it didn't give us the side 2, so we're just going to say that's x. Now, perimeter of any object is you add up all the sides. Well, side 1 is x minus 5. Plus side 2, which is just x. Plus side 3, I'm going to go ahead and distribute. 2 times x is 2x. 2 times negative 5 is negative 10. And we're going to set that equal to our perimeter. And now let's combine terms on the left side of the equal sign. X plus 2x is 4x. Negative 5 and 9 minus 10 is negative 15. All right, let me add 15 over. Leaving us with 4x equals 48. Divide both sides by 4. We see that x equals 12. And I think we had to find all sides, didn't we? Find the lengths of the side. Yes. So now that we know that x is 12, we know that side 2 must be 12. Side 1. Well, 12 minus 5 is 7. And side 3. Side 3 was twice of side 1, so it must be 14. Y'all did great.